Okay, so tomorrow we're going to be making scatterplot graphs. So let's put today's date on your notes and just title it scatterplot. And we should know a bit about scatterplots already. It's where you have an independent and a dependent axis, and then you graph your data into points here. There's several things for scatterplots. One is called a positive, they call it positive, we said positive correlation is really what we tend to use in our book. So positive correlation is when your scatterplots are increasing from left to right, it has like a positive slope. Then we say there's a negative correlation. So the variables tend to increase when the others are decreased. So usually you have like a series of points going down. So one thing has to be coming up and one has to be going down to give you a negative correlation. And then you have no correlation, which means the points on your graph are just basically scattered all over the place. There's really, whatever this is, it's not related to that at all. Okay? Positive, negative, none. So let's see, if I looked at this, these points are all over the place. So that would be a no correlation. And same thing with these. These, again, points are everywhere. So that would be a no correlation graph. Doing more. Okay. But here, when I look at this, we read the graph left to right. What is the deal with that thing? I don't know. Stop. So this one, if I were to draw a line through the points, it would be increasing. So this would be a positive correlation graph here. And then again here, the points are just everywhere. So we would call that a no correlation. Here, when I read it to left to right, clearly the points are coming down. So that would be a negative. And even here, even though they're not quite as strong as that, you at least call this a weak negative, it's still going down from left to right. And this one's a little tough because they're kind of here. And if you read it left to right, it's almost like a line coming up from left to right. So we'd probably go ahead and call that positive. And then this one is coming down. So again, that's negative. How many do you think there are of these? Holy cow. Anyway, you get the idea, I hope. That thing's crazy. Okay, so here's some more examples. Negative, right, goes left to right down. Positive, right to left. When you're drawing, this is called the line of fit, okay? So a line of fit is you try to put it through as many points as possible. And you know, to make an equation, it takes 2 points to make a line. So you definitely need it to go through 2 points here, okay? But it should be kind of scattered among this. It should be a good representation of the flow. And here we have 2 points here. And again, it should kind of go through the middle and the direction of the line. So we're going to be working on line of best fit tomorrow. So if I were going to draw a line here, okay, I want it to go through most of the points, but it needs to make it through too, okay? So I might make it go through that one, and I'm looking at this one right here. And I look, I have a good amount on top of the line and below the line, okay? So I also have to, tomorrow you're going to have to come up with the line of best fit. So I need the equation of this line, okay? Probably pick points that were a little bit tough for this, but life's tough, right? So let's just say that this was at, I could use these 2 points, but I can really use any point on this line, right? So I might even not use those 2 points. It should have these 2 points, but if I look, it clearly goes through this right here and this right here, and those would be way easier points to use. That's 0.14, and this is 0.23. So this is where we had a little bit of issues on our to get out the door. So first of all, I have to find the slope. So I know I can do y2 minus y1 over x2 minus x1, but it's so much easier just to look at what the rise and run is. And in this case, it's a down and over. So this goes down 1, over 1. So just by looking at the graph, I know my m is 1. So now there's two ways to do this, and you did this on your park projects, but I found that when you were doing that, only one or two people were doing it, not the whole group. So we need to know how to do this as a whole. So you can use point slope formula to find the equation for the line of best fit. Oops, that should be an x, sorry. Or we can plug it into y equals mx plus b. I tend to use this one because I just don't want one more equation to have to worry about. So we plug in our m, which in this case, oops, would have been -1. And then you pick a point, any point. It could be any point here. I'm going to pick 1, 4 because that seems easy. So I plug 1 in for x and 4 in for y, and then I have my b. All right? So then this is 4 equals -1 plus b, and then we add the 1, and then b equals 5, okay? I actually could have just looked here and said that was about 5, but you gotta know how to do it mathematically as well. Okay, I can use that method, or I can use this method where, again, if I use the same point, I'll do y minus my y, which is 4, plug in my slope, and x minus my x, which is 1. Then we just distribute here, so I have y minus 4 equals -x. Remember, negative makes a positive. And then I just add the 4 over, so it's in slope-intercept form. So -x plus 5. This is my line of best fit. Wow, that looks bad. Okay, so a couple things. For the line of best fit, it has to go through the center of the majority of the points. You need 2 points to do the equation of the line, okay? And it should go through, you know, sort of like its middle. It doesn't have to be exact, but it should be going through most of those points. Okay? So let's look at, I got one more example here. This one says, is this a good line of best fit? Hopefully looking at this, you should say, no, that's definitely not a line of best fit. My line of best fit should be going through these points here, right? So I might draw it something like this, so that it's going through most of the points, and there's a few above and a few below, okay? And then again, you have to get the equation for the line of best fit. So I need to figure out what the slope of this line is, right? And look, it happens to be -1 again. Think I'm doing that on purpose? And then it looks like it goes through 24 on the x-axis. So I actually could just write y equals -1x plus 24 for this. Unfortunately, a lot of them aren't quite that nice, but in this case, it worked out really good because this is my b, right? And that's y equals mx plus b. Always go for the easy if you can, right? All right, so let's look at this one. We want to draw a line of best fit. So let's see, I'm looking for my points. Might go ahead and just draw one first, okay? And let's see, I got a few below and a few above, and it goes right through one. So that's a pretty good, I might just move it over just a little bit. That's a pretty good line, right? That might not be a good angle. I think it really needs to go through that point right there. So this one would be a little bit harder because it doesn't have a nice y-intercept here, and it's not going to always. So I'm going to use these 2 points that are actually on this line, and so that is point 3, 8, right? And then this one is point 10, 20. But I can still use my rise over my run, right, to find my slope. These are going by 2s and these are going by 1s. So that's one thing you got to really be careful, because if I do my rise over run from here and here, this is going up 2, 4, 6, 8, 10, 12. That's a rise of 12 because they're going up by 2, and this is going by 1. So 1, 2, 3, 4, 5, 6, 7. So my slope is 12 over 7. So be real careful about that when you're looking at this. So again, I can use slope-intercept form or point-slope form. Doesn't really matter. So I have y equals mx plus b. So I'll choose, these are nice numbers. So we'll do 20 in for my y, 12 over 7 in for my m, 10 in for my x, and plus b. So we multiply those, that's 120 over 7. And if I do a little bit of quick math, and it's easier if you put that into the decimal, right? So we'll do 120 divided by 7. Oh, I said times, clear. Whoops. 120 divided by 7. Oh, that's a yucky number. I'm going to have to keep it as a fraction. Sorry. It was a nice try. All right, so let's see. Okay, divide that into there. So it would go in there 1, right? It goes into 12 one time with 50 left over. So that's 49, 17 and 1/7, right? I did a little bit of math here to make sure that was right. So we've got to subtract that from both sides, right? So that's a 7. So we borrow from here, make that 19, and I'll make my whole number 7 over 7. So this is going to be 2 and 6/7 was my y-intercept. Ouch. So then my line of best fit is going to be y equals 12 over 7x minus 17 and 1/7. Okay? So that's what we're going to work on tomorrow. You have to be able to take 2 points and put it into the line of best fit. Okay? And we'll end there. That took a little bit longer than I thought. See you tomorrow.